Hello, everyone. In this session, we are going to discuss some commonly asked machine learning interview questions. This question will be important for you if you are going to appear any such interview where machine learning is the topic of interest, right? Means either you go for appearing some professor post, assistant, associate, whatever the professor post in computer science, means where machine learning is in focus, or either any software developer post or data science post, this type of post where machine learning is the area of interest, then these questions are the ones that you have to go through. Well, let's start the class. First, explain machine learning, artificial intelligence, and deep learning. You know these three terms, machine learning, artificial intelligence, deep learning, they're very trending now. So you have to have a basic idea about them. So it is very common to get confused between these three in-demand technologies: machine learning, AI, and deep learning. But obviously, there exists a little difference among them, although they are interrelated. Deep learning is a subset. You can see in this figure, deep learning is a subset of machine learning. Machine learning is a subset of artificial intelligence. So as a whole, you can say artificial intelligence is a superset where these two subsets belong. And this is the super subset, deep learning, which belongs to machine learning. And again, machine learning belongs to AI. Now, artificial intelligence are those techniques that enables machines to mimic human behavior. Okay. Then machine learning are subset of AI technique which use statistical methods to enable machines to improve with experience. So machine learning are some kind of statistical methods that enable the machines to learn and improve with experience. Then deep learning, this is a subset of machine learning, which makes the computation of multi-layer neural network feasible. Got it? So now let's come to the next one. What are the different types of machine learning? Machine learning can be supervised, unsupervised, and these two are main important ones, but one more, reinforcement learning. So supervised learning, this is a model that makes prediction or decision based on past or level data. Level data refers to sets of data that are given tags or labels and thus made more meaningful. Then unsupervised learning. Let first, before going to that, first let's try to understand supervised learning through this figure. You can see here, these are the input data. Well, through this input data, that these have the tags that they are apples. This model is being trained, right? Then when some new data comes, then out of those new data, it will be able to understand, or it will able to predict that these are the level data. But in the case of unsupervised learning, what will happen? This thing will be not there. This tag will be not there. But in case of supervised learning, it will first, while we are training the model, we have the knowledge about the data set. So as I have already told you, unsupervised learning, where we do not have level data. A model can identify patterns, anomalies, and relationships in the input data. See, these are the input raw data, interpretation, unknown output, no training data set, then algorithm, then processing, then output. So what happens that through this unsupervised learning algorithm, this input data will be interpreted. Then based on some kind of homogeneity, what happens that they will be clustered or they will be segmented into different objects based on the homogeneity features. Like in this image, these are the elephants, but previously there will be no text as that we have in supervised learning, that these are the elephant, these are the camels, these are the, let's say, cows, bulls. But these things will be not there in the unsupervised learning. Only the based on the homogeneity criteria that some identical features are there for these elephants, for these camels, for these bulls. So based on those things, they will be, you can say, segmented or clustered, or you can say classified also. Then reinforcement learning. Here, the model can learn based on the rewards it received for its previous action. So, in case of reinforcement learning, what happens? Agent will learn and learn from the previous, what you can say, experiences, and based on those rewards will be given. Accordingly, the performance will be improved. So, agent, reward, environment, action. Now, for that, you can give this example. Consider an environment where an agent is walking. The agent is given a target to achieve. Now, every time the agent takes some action towards the target, it is given positive feedback. So every time the agent takes some action towards the target, it gives the positive feedback. And if the action taken is going away from the goal, the agent is given negative feedback. So I hope it is clear to you what is supervised, what is unsupervised, and what is reinforcement learning. Next question, what is overfitting and how can you avoid it? Well, see, in this figure, you will see the difference. This is an appropriate fitting, this particular graph. Now, in this particular graph, the situation shows is a kind of overfitting problem. Now you will understand that why these things are happening. Because this is the situation. The overfitting is a situation that occurs when a model learns the training set too well, taking up random fluctuations in the training data as concept. This impact the model's ability to generalize and don't apply to new data. Say, when a model is given the training data, it shows 100% accuracy, technically a slight load. But when we use the test data, there may be an error and low efficiency. And this condition is known as overfitting. So for the training data, 100% accuracy with a little slight loss will be shown. But for the test data, there may be an error and low efficiency. And this is because of this condition of overfitting. Why this is occurs? Why this is occurring? Because the model learns the training set too well. Okay, it means it learns the training set very good. But while taking up random fluctuation, the training data, this concept, the model's ability to generalize, so it will not be able to perform well for the new data. Now, there are multiple ways of avoiding this overfitting problem, like regularization. Regularization involves a cost term for the features involved with the objective function. Now, making a simple model with lesser variables and parameters, and the variance can be reduced. Cross-validation methods like k-folds can also be used. If some model parameters are likely to cause overfitting, then techniques for regularizations like Lasho can be used that penalize these parameters. So you just remember the overfitting problem and some measures for that. Measures for dealing or tackling this overfitting problem. Now, what is bias and variance in machine learning? Bias is the difference between the average prediction of a model and the correct value of the model. So, what is bias? It is the difference between average prediction of the model and the correct value of the model. If the bias value is very high, then the prediction of the model is not accurate. Because see, this is showing the difference between the average prediction and the correct value. So if it highs, means the prediction is not going to be accurate. Now, hence the bias value should be as low as possible to make the desired prediction. Now then, what is variance? Variance is the number that gives the difference of predictions over a training set and the anticipated value of the other training sets. High variance may lead to large fluctuations in the output. Therefore, a model's output should have low variance. So what is variance? In short, you can say this is the difference of prediction over a training set and the anticipated value of other training set. Okay, so high variance means large fluctuations. You can see in this diagram, low variance, high variance, low bias, high bias, low bias, this one, high bias, this one. Okay. Now, The desired result is the blue circle at the center. If we get off from the blue section, then the prediction goes wrong. You can see this case, right? This is the desired result, and see what is happening in the other cases. Now, how do you choose which algorithm to use for a data set? Common question. See, apart from the data set, you need a business use case or application requirements. What is your application requirement? Now, you can apply supervised and unsupervised learning to the same data. Supervised learning algorithm requires level data. You know that in level data means you should have some knowledge. You should have knowledge about that data, right? Level data, tag data, right? Now, in case of supervised learning algorithm, regression algorithm require continuous numerical targets, while classification algorithm requires categorical targets. So whenever some values are concerned, in case of supervised learning, we go for regression algorithm. And whenever some categorical targets are there, yes, no, fail, pass, this type of categorical target, then we go for classification algorithm. While unsupervised learning algorithm require unlabeled data. Then semi-supervised learning requires the combination of both labeled and unlabeled datasets. And reinforcement learning algorithms requires environment, agent, state, and reward data. Environment, agent, state, and reward data. See, this is the whole diagram. Machine learning, supervised, unsupervised reinforcement, regression, linear polynomial, right? Then clustering. In case of clustering, we have K-means, very famous one. Then PCA-SVD, right? Then these are the continuous, means the numerical values are associated. Then decision tree, random forest, they also fall under supervised. And in case of classification, apart from regression, classification, what we have? We have KNN, trees, logistic regressions, naive-based SVM. Then again, in case of unsupervised, we have association analysis like a priori algorithm, FP growth, hidden Markov model, and they can also work in the categorical cases. Now, what is training set and test set in a machine learning model? How much data will you allocate for your training, validation, and test series? Very, very important question. So, three-step process followed to create a machine learning model. First, you will train the model, then you will test the model, then you will deploy the model. So what is the difference between training set and test set? Training set is examples given to the model to analyze and learn. Means basically with the training data sets, you are trying to teach the machine. So 70% of the total data is typically taken as training data. So maximum amount of data are actually fall under this training, and actually you can say push to the training data set. This is label data used to train the model. So everything is clear about training set. Now test set. This is used to test the accuracy of the hypothesis generated by the model. So you see 70% assigned to the training set, how much left? 30%. So remaining 30% is taken as testing data set. We test without label data and then verify the results with labels. So consider a case where you have label data for 1,000 records. One way to train the model is to expose all the 1,000 records during the training process. Then you take a small set of the same data to test the model, which should give good results in the case. But this is not an accurate way, because so we set aside a portion of the data called test set before starting the training process. Remaining data is called training set, what we use for the training model. Means what it is stated, out of 1,000 model, you keep 70% of 1,000 as for training, and then remaining 30% for testing. Train and fit a model, train set, 70% train data, pair input to expected output. Then test the model, test set, 30% test data, estimate the accuracy of the model. Now, if someone asks you that how to split the data into training and training and test data sets, then let me tell you that there is no such fixed rule. The ratio can be also varying with respect to individual preferences. You may take 80% to 20%. Some may take 75, 25, like that. Okay. So there is no hard and fast rule for that. The main condition is that keep maximum data for training, minimum data for testing. Well, let's come to the next question. What is clustering in machine learning? Clustering, a technique that we use in unsupervised learning. I told you, unsupervised learning for unlabeled data. This clustering algorithm, what will it will do? It will classify the data points into some groups. These data points that are thrown into the same category have similar features and properties, while data points that belong to different groups have distinct features and properties. Statistical data analysis can be performed by this method. You can take an example of this. See? Trying to determine the appropriate audience for the product, using clustering algorithm on the customer base, then selling the products to the target audience. Means this particular items to be sold to this age group, say 10 to, 10 is very small, of course, say 18 to 25 age group, then 25 to 35 age group. What are their preferences? Accordingly, the selling products will be shown to the browsers of those different means online websites for shopping. So in this way, you can means cluster your customers based on their preferences, right? So one famous algorithm is K-means clustering algorithm, where K is used to represent the number of groups that data will be divided into, and data points are clustered using the similarity of features. And the centroids of the cluster are used for labeling the new data. Then similarly, mean shift clustering. The aim of this algorithm is to update the center point candidates to be mean and find the center points of all groups. In mean shift clustering, unlike k-means clustering, the possible number of cluster need not be selected, as it can automatically be discovered by the mean shift. Yes, some may ask you again that what is the disadvantage of k-means clustering algorithm? Then you should say that one disadvantage we can say here is that the number k, because this k should be given beforehand, and there is no such particular method for a respective data set that this method should use for this, that to determine. So you should have a better statistical method to find out the k beforehand. Otherwise, random giving k may lead to some incorrect results. But still it is very popular, and some means solutions for this problem also happens to occur time to time, right? Like elbow method. Well, then density based spatial clustering application with noise, db scan. This is based on density and has similarity with mean shift clustering. No need to preset the number of cluster, but unlike mean shift clustering, DBSCAN identifies outliers and treats them like noise. Moreover, it can identify arbitrarily sized and shaped clusters without much effort. So clear about clustering? Let's come to the next question. How come logistic regression is labeled as a regression method when it is primarily used for classification tasks? Well, logistic regression earns its classification primarily due to its historical connection with linear regressions. However, its paramount utility lies in addressing the classification tasks, given its remarkable ability to model the probability of an observation belonging to a specific class or category. In practice, it quantifies the likelihood of an event's occurrence, and knowing it with great significance in tackling classification challenges like discerning spam means spam emails is a very important area of research, where it means some already very efficient methods being developed, where you can means identify that these are the mails that may be tagged as spam, because we don't have enough time to go through all the emails. We want important emails in front of us, right? Then, despite its nomenclature regressions, its predominant functions is in terms of classification, which explains its frequent association with the classification algorithm. And this explanation is intended to be informative, ensuring originality and search engine optimization. Then next question, what is linear regression? So in machine learning, this is a supervised algorithm, of course. It is used to find a linear relationship between dependent and independent variables of predictive analysis. So an equation is very common here, y is equal to a plus bx, where x is the input or independent variable. Why? Because from the equation, it is very clear that y is depending on x, because y value can be found from x, a plus bx. So x value is needed to find out the value of y. That's why x is the input or independent variable, while y is the output or dependent variable, and a is the intercept and b is the coefficient of x. Now below is the base fit line that shows the data of weight y or the dependent variable and the data of height x or independent variable. So this side x, this side y, and this diagram is for 21-year-old candidates scattered over the plot. Okay, you don't need to concern about that, but just remember that some points are there and some line tries to actually means find out a relationship, base linear relationship that will help in predicting the weight of the candidates according to their height. So height x, weight y. So we are trying to predict what? We are trying to predict weight, because weight is this the y, that is the output, or you can say dependent variable. Now to get the base fit line, the base values of a and should be found. Very obvious. By adjusting the values of a and b, the errors in the prediction of y can be reduced. This is how linear regression helps in finding the linear relationship and predicting the output. So very clear to you now, linear regression, y is equal to a plus bx, a intercept, b is the coefficient, x is the independent, and that the y is the dependent variable. Common example is the height weight problem. We try to find out the weight with respect to height using linear regression. Then last question of this lecture, because I'm now in this lecture, actually I'm trying to specify top 10 commonly asked questions. Obviously, some other lectures on interview questions for machine learning will also come. But this top 10 question you should not avoid. The last question is that explain the k-nearest neighbor algorithm. K-nearest neighbor algorithm, this is a supervised learning classifier. It uses proximity to classify levels or predict the grouping of individual data points. We can use it for regression and classification. Okay. And KNN algorithm is a non-parametric, meaning what? Non-parametric means it does not make an underlying assumption of the data distribution. Here, k nearest neighbors, okay, you can say k neighbors, we will find nearest, and based on those neighbors, means we will detect that which will belong to which group and which will belong to other groups, right? So in this lecture, I will complete 10 questions. Rest of the question I will discuss in the coming classes. Okay. And still, if you have any doubt, then let me know through a comment. Thank you. All the best.